We are about to witness a moment unlike anything in human history. In just a few days, something remarkable will unfold, and at the very same time, something frustrating. Atlas, the third known visitor from another star system, is arriving at the hottest point of its swing around the sun. This should be the clarity point, the instant when its secrets finally come into focus. Instead, we're about to lose it from view entirely. Picture sitting down for the most important film of your life, only for the screen to go black at the climax for 6 long weeks. That is what astronomers are facing. Starting tomorrow, for a crucial month and a half, our instruments, from backyard scopes to the most advanced observatories, will be effectively blind. Nothing is broken. The sun itself will flood the sky, washing out anything close to it the way a stadium light overpowers a candle. And that is exactly why nerves are on edge. If anything wanted to change course without witnesses, this would be the moment to do it. The final data before the blackout was a shock. The James Webb Space Telescope reported a measurement few expected. Atlas shows roughly 8 times more carbon dioxide than water. For a comet, that is upside down. Think of someone drinking 8 glasses of soda for every single glass of water. In ordinary comets, water is the main ingredient, the flour in the bread. Here, the proportions flip, like baking a cake mostly from sugar with almost no flour. The deviation is so extreme that scientists describe it as a 6 sigma outlier, the statistical equivalent of meeting a person 10 feet tall when the average is barely over 5.5. And the surprises continued. Japanese observatories looking at the coma, the temporary atmosphere that forms near the sun, found strong nickel emission but almost no iron. In nature, iron and nickel usually travel together like twins. Finding one glowing without the other is like discovering a rich gold vein with no iron anywhere in the mine. Now to why the sky goes silent. When Atlas passes behind the sun, this isn't like stepping behind a tree and peeking around the trunk. The sun is a blinding spotlight that drowns out anything within a tight angle, creating a brightness dead zone. Imagine trying to pick out a candle placed next to a searchlight. Even if the flame is slightly offset, all you see is glare. That's what our telescopes confront. The blind region spans more than 1 million miles in projection, and no trick, visible light, infrared, even radar, will cut through the glare. Atlas will glide to within about a degree of the sun as seen from Earth, less than the width of 2 small coins held far away, except those coins are a 1,000,000-degree fireball. This is why the timing is unnerving. If you were planning a move you didn't want anyone to see, you'd choose the minute the cameras go down and the guards head to lunch. If Atlas is any kind of engineered craft, and a few serious voices keep that possibility on the table, this window is the perfect cloak. Over the next 6 weeks, anything could happen. The object could fragment, alter its outgassing pattern, or even pivot onto a new path, and we would miss the act itself, like closing your eyes during the big reveal in a mystery. There's also the path Atlas took to get here. Out of the immeasurable rubble adrift in the galaxy, only 3 such visitors have been spotted since modern surveys began. The first 2 arrived on steep, awkward angles, like aircraft flying far above or below the normal traffic lanes. Atlas, by contrast, slipped in almost exactly along the plane where the planets travel. It feels intentional, like knowing precisely which lane to take into a crowded highway. The odds are lousy. Imagine someone throwing a ball from another country and having it land right on your street. Possible, but not likely. Stranger still, the timing lined up to pass near Mars, then Venus, then Jupiter, like a tourist itinerary through the solar system's highlights. That's why one hypothesis turns heads. Harvard's Avi Loeb has suggested Atlas might not be a standard comet at all, but a probe using the sun's gravity as a curve to change course. If so, the critical maneuver would happen while the object is hidden in solar glare, exactly when our view is gone. The next real test comes when Atlas returns to view in December. If its position matches the predicted ephemeris, it likely behaves like a very odd comet. If it's even slightly off, something happened during the blind stretch. The measurement will be extraordinarily precise, akin to spotting a quarter from 1,000 miles away. A tiny change corresponding to roughly 30 feet per second in velocity would be hard to square with normal comet physics. Ordinary gas release is too gentle and too gradual. That sort of nudge suggests a prompt, directed push, the difference between being moved by a breeze and being driven by an engine. There is, however, good news for the long game. A new generation of sky surveys now sweeps the heavens every clear night. What once felt like searching a haystack for a single needle every few years is becoming a steady flow of discoveries. Dozens of interstellar visitors per year may soon be routine, giving us the sample size to tell whether Atlas is a true outlier or part of a hidden population we've barely started to notice. When Atlas emerges from behind the sun in December, the verdict begins. If it sits exactly where celestial mechanics says it should, then we're probably dealing with the strangest comet on record, still natural, just rare. If it's displaced even a little, then assumptions about interstellar visitors will need a rewrite. For now, Atlas remains a question mark wrapped in a luminous shroud, about to slip behind the brightest object in our sky. The countdown has started. In a few weeks, we may be closer than ever to answering a very old question. Are we alone? But first comes the quiet. Tomorrow, the silence begins, and that silence has never mattered more.